welcome. In this video, we're going to be finding the value of IB using superposition theorem, and we're going to consider each power source individually. And the first power source we're going to be considering would be this voltage source. In order to consider this voltage source as acting alone, we're going to have to turn off the remaining voltage sources. In other words, we're going to replace the voltage sources with short circuits and the current sources with open circuits. As we have two voltage sources here, no current sources, so we're going to be replacing this and this with short circuits, and we'd have a circuit that looks something like this. Now IB is the current that flows through the 4 ohm resistor, and to find IB, we just kind of resolve this circuit. Now if you look very closely, you would realize that these two resistors are in parallel with one another, so we can kind of redraw the circuit to look something different, something like this. Pardon my error here. So you notice that you can combine this into one parallel resistor. So then the next thing you can do is combine these two into another parallel resistor, so that the resultant is two resistors in series, and that circuit that we have will look something like. Now, with this equivalent circuit, we can then find the total current flowing in this circuit due to the 70 volts power source. Let's call that I1, and that current would be I1. If we call this current IB1 equals 70 volts divided by 4 in parallel with 20 plus 2 in parallel with 10. 2 in parallel with 10. So there is the value of the current flowing in the circuit. We can then come here and use the current divider to find the value of IB1. So we know the total current flowing in the circuit, that's I1 here. Then we can say that IB1 equals I1 multiplied by 20 over 24. So that is the value of IB1. If we simplify this current further, we would have it that I1 is equals to 70 divided by this would amount to 10 over 3. That is 10 over 3, and this would amount to 5 over 3. That is 4 times 20 divided by 4 plus 20, 2 times 10 divided by 2 plus 10. And then the final answer would be 14 amperes. So we know that IB1 would be 14 multiplied by 20 over 24. Remember, we're using the current divider formula here, and this would overall be equals to 35 over 3. In essence, we are saying that the current IB, that is the current flowing through the resistor due to this power source, is 35 over 3 amperes. Now the next thing I want to do is to find the value of IB due to this 50 volt power source. In other words, we will be turning off these voltage sources while leaving this one on. So replacing this with short circuits, and the circuits will look something like this. And if we look quite closely, we would see that these two resistors are in parallel with one another, and if they're in parallel with one another, we can redraw this circuit combining these two resistors, and we have a simpler circuit. The simpler circuit will look something like this. And since it is obvious that these two resistors are in parallel with one another, this circuit can further evolve into something that looks like this. And we can then write an equation for the value of current flowing out through due to this power source, and we can call it I2 equals 50 divided by 10 plus 4 in parallel with 2 in parallel with 20. And now this basically amounts to 50 divided by 45 over 4, which then equals 40 over 9 amperes. So that is a value of I2, and then IB2 would be we would have to use a current divider here at this junction to find the value of IB2, and that will give us IB2 equals 20 in parallel with 2 multiplied by I2 divided by 4 plus 20 in parallel with 2. That is the current divider, and as such this would be 20 over 11 to I2 over 4 plus 20 over 11. Okay, and if we put in the value of this 40.9, everything should amount to 25 over 18 amperes. And then what we have here is the value of the current IB due to this power source, that is the effect it has on generating current IB, which is IB2. The next step would be to turn off these two voltage sources and leave this one on, so that we can know the value of current due to that power source. Now for the third power source, we have a circuit that looks like this, and if you look closely, you see that these two are in parallel with one another, so we can combine them into a simpler circuit so that looks like this one over here. And what you see is that this circuit can further evolve into a circuit that combines these two as one single resistor in parallel, so we can then have a circuit that looks more like this one. And what you see is that you can then calculate the current, total current coming out through this power source I3 as 2 IB over 4 in parallel with 10 plus 2 in parallel with 20. We can then proceed to use a current divider here to find the value of IB3. If you call this up, we know that this is I3 and this would be IB3, so we know that IB3 is 10 using current divider over 14 I3. Since they are flowing in opposite directions, this will be negative. We can then say that IB, since we can then simplify this and say 2 IB equals this would be 20 over 7 plus 20 over 11, and all of this will amount to 77 over 180 IB. We can then substitute that here, and this would give us minus 11 over 36 IB. So this would be IB3. So we expect IB3 to be equals to minus 11 over 36 IB. So we can then go back to the rules of superposition theorem and sum up IB1, IB2, yeah, and IB3. So we know that IB equals IB1 plus IB2 plus IB3. And as that is the case, so we would have IB1 35 over 3 plus 25 over 18 plus 25 over 18 plus minus 11 over 36 IB equals IB. We can bring this over to this side and collect like terms. With that, we would have it that IB is equals to 35 over 3, 25 over 18 over 1 plus 11 over 36. If you use your calculator, you should arrive at your answer as 10 amperes. So we know that the value of IB is 10 amperes. That will be all for today. Don't forget to hit the like button and subscribe. See you next time. Bye.